Hey, stats class, this is section 10.2. We started, so I'm going to kind of catch you up here because I forgot to record. So 10.2 starts with a regression, and we said a regression line is the same thing as a trend line, which is a line of best fit. All of those mean the same thing. This is what a trend line looks like, or a regression line looks like. The computer system will slap a line on there that's supposed to be close to all of those dots, and we said because it is a line, it will be y equals mx plus b for the formula, okay? This is slope-intercept form because it's literally slope and intercept, okay? Are we good to go? Now, I am somewhat aggravated, listen, I'm somewhat aggravated with the way that your book represents this because they say a regression equation looks like this. They call it y hat, which is the same thing as y, but where's the m?
B-O! No, it's B1.
B1. B1 is the m. So they put b plus mx, right? But they call B0, right? B0 is your initial b, which is where it intercepts the y-axis, right? Okay? And then they call your m your B1, and they write it in a different order, okay? So on the computer, when we have them do regression lines, it may be backwards. It might be that your m is second and that your b is first, okay? And they use those variables. They use B0 and B1. Okay, B0 is your initial one. That's the original B, and the B1 is your M. So they might use different variables. I don't know why they do that. It's just basic algebra to me, but they're using different variables. Okay, happy with that?
It's basic algebra, but
Yep.
different.
Right. Okay. So let's go down here. And here is the formulas that they use if you're doing the longhand version of finding the B1 and B0, okay? Here is how you find the slope and y-intercept given your data. Okay, watch this. Your B1, which is your m, which is the slope, is found by taking that r value, whatever your r value is, and the computer system will spit that out, or you can calculate it, okay? And taking that times the sy over the sx's, okay? And sy is the standard deviation of all the y values. Not too hard, right? And sx is the standard deviation of all the x values, okay? Which you can find. You guys have found the standard deviation before. That will give you your slope. So you take that r, and you take it times the standard deviation of the y's over the x's. Why do they put the y's over top of the x's?
Because the y's are better.
It's rise over run.
It's rise over run. So don't get that confused because it's the same thing for y2 minus y1, x2 minus x1. The y's go on the top because it's the rise over the run. So those are just your standard deviations you're dividing, okay? Your b naught, which is your y-intercept, is y bar. What is y bar?
The average of y.
The average of the y's. They don't label that, so let's go ahead and say mean of the y values. Okay, and x bar is the mean of the x values. Okay, what's B1? Whatever our number is from up there, right? That's how you calculate your B0. Yeah? Good? Yes, yes. Okay, your B1 and B0 can also be found using the following formulas for manual calculations.
No, we're not.
Okay. We're going to see if we can use that other thing, these other formulas. Okay. We're going to calculate a B.
Yay, we're done for the day.
Okay. No.
We
We're going to do example one
yet.
Example one.
Calm down, Cody.
All right, refer to the sample data in the table 10.1 in the chapter problem. Okay, we have chocolate consumption and Nobel Prize winners, right? Okay, so I'm going to have you copy this table down.
Why do you really like this chocolate and Nobel Prize?
I don't know, that's just the data that they given to us. Okay, we're going to actually, at the end of this chapter, we do like a chapter project, and I haven't quite decided. In the past, we've always done like,
Instead of a test?
no. We've always done like wingspan versus height to see if they're correlated because they're supposed to be the same. I may change it. We'll see what we do. Okay, we're talking about. So if you have any good suggestions, let me know of things that you want to compare to see if they're related. One thing. This was interesting, and I have to figure out how to put it into a project. But one thing that my Mr. Brown and Mr. Deal, which would be my uncle and brother-in-law, right? Mm-hmm. They were fighting this weekend about whether or not, because it was state basketball weekend, they were fighting about whether or not parochial schools show up in the state tournament with more frequency than like
Oh, yeah, they can
public
use
schools,
these.
right?
They get to recruit more people.
So,
They can
so they were
literally
trying
go
to figure
and
that out. I'm like, oh, that'd be an interesting stats project to see if it's a significantly large enough to say that they do have an advantage over public schools.
And then we can
interesting.
make it to
Be an
where
interesting
they'll
project.
have a
Question.
parochial
Right?
tournament and then
Question.
a regular
It'd be an interesting
tournament.
project. So anyway, what?
Do we have a semester final?
No.
No.
We'll do a bunch of projects and stuff, but no.
We don't have any
Does
semester.
somebody from your 10-1 notes have these values?
Asked if we did one.
Give me the chocolate data and the Nobel Prize winning data.
I thought you were talking about-
Coach, we don't have this.
But I'm saying.
Well,
in the
here, write this
past,
down.
I've seen it.
I have it right here.
Oh.
10-1. Write this table down.
No.
Fill in these numbers. Chocolate.
Out of the stacks.
Somebody do this. Chocolate. 56445 is chocolate. Okay. Nobel Prize winners. 693211. Write that down and then give them back to me. 56445 693211.
Okay.
Okay. Scroll down.
69311.
693211. I'm gonna have it given back to me. 693211. Okay. What's the other one? 56445. Okay.
Okay.
Use technology to find the equation of the regression line in which the x variables are the chocolate consumption, which we have listed as our first line. The y values are the Nobel Prize winners. So we're going to type these into Google Sheets and we're going to have it spit out a formula for us. And I think on my recording here, it's not going to like that. So you guys aren't going to be able to see what I'm doing right now. Okay? Stats random sheet right here. I have this very data, and this was what we had the last time. How do I view my
Too good to me.
right pane over here? Data. Somebody help me out here.
Oh, shit.
Where do I
Click
go?
the three bars.
No. I want like the stuff on the side, the customized. What?
Click the three
Click
bars
the
and
three
edit.
bars.
Haha. Okay.
3 bars, those are dots.
Edit chart. Yeah.
You know what? Both said they're bars, so they're bars.
Ah, there we go. That's what I want. Okay. So, come on.
Wow, Coach.
Edit chart. I'm on the struggle bus right now. Okay. Let's go down to where we say customize. And we want to go to, I think it's series, trend line. But I want to go down to where it says, nope, custom label. No, label, use equation. You see where I have it here? Watch this. Are you watching?
Oh my goodness.
Okay. It's under the series. You go down, and we switched on that we wanted to show the R squared value. We switched on that we wanted to show the trend line. But if you go to custom, and it says use equation, look at the top here of my chart. There's my equation. Okay. There's my equation for my stuff. I think. Did that do what I wanted it
I
to?
have no idea.
Come on. I don't know if that did what I wanted it to do. Use equation, show R squared. There we go, that's what I want, right there. Okay. All right, so y hat equals, and they write it with the m first. So this is 3.64 x plus negative, actually it should be minus 11.3. Okay. Write that down on your paper.
3.6.
Okay, there it is. Okay, 3.64 plus minus, I'm going to just say minus, minus 11.3. Where am I getting this information?
Like, why are you going this route?
What? Because they say use technology to do it.
Oh, okay, I'm using different technology.
Okay.
Cody,
Did you get the same kind of ish thing that I got?
Cody, your technology.
I don't know, I'm doing different.
Okay,
So
so
go back.
using this information from up here, 3.64x plus minus, really I'm just going to make it minus 11.3.
Minus 11.
Plus minus 11.3, I'm just going to make it minus 11.3. So this is the equation that the
3.
Google Sheets spits out for us, yeah? Okay. Now, in this, what's the slope? Let's maybe label this stuff. What's the slope? 3.64. This is my m. They call the m b1. So I'm going to put that in parentheses. This is my y-intercept, which they call b0. Okay, so if they ask for that, that's
Why
that.
can't they just make it all the same thing?
Oh no, because they're going across to
You
like.
went that way.
different,
I
whatever.
understand that.
Did you get about the same thing I did?
Well, I'm still finding my numbers from
Oh,
it.
Cody's too dumb.
Doing her different.
That's what we're doing in example 2.
Well, the hell with that.
Use technology to find the equation.
Whoa,
There you go.
there we
That's
go.
that's all we needed to do was find the equation. Now they're gonna have us find the equation
We need to
different
make not
in
20.
example 2. Refer to the sample data given in table 10.1.
We need to make not 20.
And they want us to use the formulas 10.3 and 10.4, which we're not going to do. We're gonna use these two right here to find our B1 and B2. So M equals B1,
But then the chips
and
get
that
soggy.
is R
Huh?
Then the
times,
chips get soggy.
shh, you gotta be quiet,
You get soggy.
SY over SX.
No.
Y-intercept is B0.
Okay, so you'd rather have.
I
6
can't
chips with
think when you're
toppings
talking.
And the rest of them just plain
Shh.
chips.
I like soggy chips.
Oh my pee.
Minus.
Shut up.
B1 X bar.
Okay.
Okay, so
Cody always
those are
has
the
to
two
know
formulas that we need, and we're going to calculate our
My
equation
bad.
here and see if it's any different than what we got from above. So, you people that have the capabilities to find the standard deviation, aka Cody and maybe Erica Boyd, I don't know. You guys that have fancy calculators, you go through and calculate the standard deviation of these guys. Couple other people, go through and find me the means. You guys can do that on just a regular calculator.
What am I
Find me the means, find me the standard deviations of the x's and y's.
Okay, yeah, I got all.
Okay?
S of x.
Do we trust Cody though?
Yeah,
I
these
don't
numbers
know,
are
'cause
coming
I don't
out.
know what I'm doing. I don't
S
know
of
what
x
Okay.
equals
Because-
0.8367.
All right. S of x, that's the standard deviation of all the x's. You said was what?
0.8367.
0.8367. Okay.
X bar is 4.8.
Okay. 4.8.
SY is 3.8341.
3.8341. Okay.
Y bar is 6.2.
And the average of the y's is 4.62.
And the R is 0.7949.
0.7949. We calculated that before, right?
All right, now
We got
here's the real
0.795.
question. How sure of this are you? Cody?
I know that his R value is correct.
My B1 came out right. So
Okay. So let's go ahead and plug these numbers in. So the calculator or the computer or the Google Sheets gave us that formula. We're going to see if we get the same formula. So the R value, 0.7949. We're going to take that times the standard deviations divided, but the Y goes on the top. So 3, is that right? The standard deviation of the Y's? Yeah, that should be. Why is that one so much bigger than the other one?
Because the math said so.
Why is this standard deviation bigger than this standard deviation? Look at your numbers.
Because
You
for the
got
walls.
11.
You got 11 in there, right? That's
Yeah.
making 11 to 2. That's making a really wide range, okay? So that's why. All right. It's good to think about those things so you know that you're not making a mistake and it's actually legit, okay? If you do that math,
Ed.
0.7949 times that stuff divided,
Special.
what do you get for your B1 or your M value?
3.64.
Is it exactly 3.64?
3.64255538.
We'll go 26. There you go. 3.6426
That's what we got.
is what that guy is, okay?
Why
This
are
guy
you
equals-
that small?
I don't know.
The
Because I want to
next-
make sure that's correct. Y bar is 4.62 minus, we're going to take B1, which was that 3.6426,
Mhm.
and we're going to take it times the X bar, which is 4.8.
And you get negative 11.28.
Wrong.
11.28,
Yeah.
okay? So the numbers that we got, that wasn't terrible calculations to do, right?
It all rounds
those
out
aren't
the
too
right way
terrible.
you got it.
I don't know.
Is
Cody, how
is
bad
that
was
is that what we got from up here?
Wasn't bad. Mhm.
Yeah. So if I write my formula out according to these numbers, y equals 3.6426 if we want to go out 4 decimal places, x minus 11.28. Pretty well the same as what they got up here, okay? So this is, I'm just showing you in this second example, this is what the calculator does every single time it spits out one of those regression equations, and it does it in like a half a second, right? But this is all the math that is involved in finding that. Okay? Yeah?
Dunzo.
Donezo? Okay, I'm going to give you your 10-2.
No.
And you can do, well, then it just cuts down on what you have to do later, right?
No.
Okay, 10-2. Let's look at what all you have to do before I give it to you. Okay. Use the given data to find the equation of the regression line. Examine the scatter plot and identify a characteristic of the data that is ignored by the regression line. So, this one you're going to have to use Google Sheets. Go onto Google Sheets and
Why?
plot it. Because
Can't enter my calculator.
do you know how to plot it and look at the scatter plot?
Why do I need to plot
Hey, are
it?
we gonna need
Because
that?
examine the scatter plot and identify a characteristic of the data that is ignored by the regression line.
Scatter plot, that's why we gotta have a
It
scatter
says
plot.
look at the scatter plot with the line also.
4.
I can show you how to do that on your calculator.
Okay.
But anyway.
Can I recycle chapter
All right,
1
number
and 7?
2. Use the data to find the equation of the regression line. Do the same thing again. So do 1 and 2. And let's have you just do that. 1 and 2. Okay, that's enough. All right, so go onto Google Sheets, or if you have a graphing calculator, I can show you how to do that. Find the equation of your regression line, and then see what I'm probably guessing when they say examine the scatter plot and identify characteristics that are ignored by the regression line. It's probably not taking into consideration maybe an outlier that lives in your data, so kind of take a look at that and see if that's what they are addressing there, okay? All right, good? All right, there you go. I'm going to stop the video.